So every merge tree stores data in parts on disk. They periodically merge them into bigger parts. They use a sorting key and can be replicated or distributed. What changes is the merge behavior depending on the type of merge tree, okay? Let's see a quick example to understand how the merge tree family works. So let's start by creating an events table. It's gonna be a merge tree partitioned by month and ordered by date and user ID. So I'm gonna insert just 4 rows, 2 rows in October, 2 rows in November. So if I take a look at the system parts on this table, we're gonna have 1 part in October, 1 part in November, 2 rows in each one. Okay, so this happened on insert. What happens if I run another insert with another 4 rows and I take a look again at the system parts? We're gonna have 2 parts in October, each one with 2 rows, 2 parts in November, each one with 2 rows, okay? Even when we have multiple parts for each partition, whenever I do query, it's gonna merge or query the different parts on disk and it's gonna give us the result, okay? In this case, if I filter by the 1st of October and user ID 1, we have 2 rows, okay? That's perfect. Now let's see how indexes work. If I show the table again, we see the table was ordered by date and user ID. So let's run and explain indexes on this query in which we are filtering by a date and by user ID. And what we're gonna see is we have several indexes when reading data. We have 1 on the date column and it's gonna filter 2 out of 4 parts because we are filtering by October and in October we had 2 parts. And then it's gonna try to filter also by the partition and by the primary key. In this case, it's not gonna filter anymore, okay? If I change this query and I do a greater or equals than October, then we're gonna see this first filter is not gonna filter anything because all the data we have in the table is greater than October, okay? So this is how data skipping indexes work in ClickHouse. Now let's take a look at the ReplacingMergeTree. Let's say we have this users table. We're gonna set a ReplacingMergeTree on updated add, which means this is the column that indicates the version for each primary key, okay? So whenever we have a duplicated ID, it's gonna take the latest updated add, okay? So let's see an example. If I insert in this table the same ID twice, the ID number 1, and we're gonna have Alice, Alicia, and then Bob. But Alicia is gonna have the latest updated add, so it's gonna be deduplicated, okay? So now if I do a select, we're gonna see that the latest version is Alicia. This happened because there was a merge under the hood, but if I try to do the same again, let's say I do this and I select, we can see duplicated rows, okay? We are now seeing Alicia is twice and Bob is twice. So sometimes you have to use the final keyword when working with ReplacingMergeTree. So even when you have background merges, you want to also run the merge at query time, okay? So running the final in the query, it's gonna deduplicate the data. Let's see now an example of a SummingMergeTree. This is gonna be a table to count page views. We define the SummingMergeTree engine, and it's gonna order by date and user ID. Basically, you order by any column that you're not gonna sum, okay? In this case, we're gonna sum views by date and user ID. Let's insert some data. So we're gonna have the user number 1 with 1 view in 2 different dates. and the user number 2 with 3 views. If we run a query over this table, we are seeing that for the user ID number 1, it already summed all the views. Let's do another insert. Now, if I run the very same query, we're seeing it didn't sum yet the different parts. So in this case, just for the sake of the example, we can force the merge of these parts, and we're gonna see how the user ID number 1 is gonna have 4 views. Okay, so let's run again the same insert. You can do the aggregation at query time, and it's gonna return a proper result. Okay, so we are seeing here like the mechanism of the merge tree, in which whenever you do an insert, it creates new parts. Eventually they got merged by a background process, but you can force the merge at query time by writing the proper query. Let's take a look now at the AggregatingMergeTree. Basically, when working with the AggregatingMergeTree, you have like a raw table. In this case, we're gonna have user IDs and duration of each session, regular merge tree, not partition, ordered by user ID. We're gonna insert some values in here. And we're gonna do now is we're gonna create a new table in which we're gonna sum the duration of all the sessions for each user ID. We're gonna use an AggregatingMergeTree and order by user ID. Usually order by any column that it's not aggregating, okay? Take a look at this function. We will talk about it later. So if we now insert in this AggregatingMergeTree table, we need to pre-calculate aggregated states. Usually do it by using this suffix in the aggregate function. And whenever you want to query that table, you have to use special aggregate function, which merges all the states, okay?